Hello and welcome back to Reimagining Cyber. My name is Ben, and joining me today, as normal, is Tyler Moffitt, the Senior Security Analyst at Open Text Cybersecurity. Hey Tyler, how you doing?
Hey, thanks for having me on. I appreciate it.
Now Tyler, our last episode involved ransomware stopping milk production, but today we're moving into, much more alarming territory, a nuclear power plant.
Yeah, I want to establish here real quick, important distinction immediately. There is no evidence that hackers compromised the nuclear reactor specifically, or any nuclear safety system, or any nuclear security system. What reportedly happened is that ransomware group published thousands of files connected to a contractor working on, India's Kudankulam nuclear power plant, which is I think, the biggest power plant. So might not be as dramatic as hackers taking control of a nuclear reactor. I mean, this isn't Stuxnet 2.0, but it's still very significant, right? The attackers allegedly obtain engineering drawings, facility layouts, supply information, inspection records, meeting notes, correspondence, and a lot of equipment photographs, which is still very, very dangerous, right? They didn't need to penetrate the most heavily protected part of the facility to obtain that information surrounding it. But it still makes the story definitely worth examining.
Let's begin with the facts then. Where did these files come from?
So they were published by an extortion group called World Leaks, different than WikiLeaks, World Leaks. And security researchers identified about 19,000 files in about 14.3 gigabytes to India's most powerful, biggest power plant, nuclear power plant, Kudankulam. And those files were much larger collection allegedly taken from Reliance Group. The full collection of this dump is about 850,000 files. And so Reliance Infrastructure was awarded a contract in 2018 to design and construct a non-nuclear common service facilities for units 3 and 4 of the plant. And so Reliance acknowledged what it called a partial breach involving data stored on a server hosted by Yoda, which is an Indian data center provider. And the Indian government was informed. Yoda said it detected suspicious activity the end of May, beginning in June, and involving a Reliance infrastructure, according to Yoda. And it terminated the activity and prevented the suspected ransomware execution, allegedly. However, preventing ransomware from executing does not necessarily prevent data theft, and that's what we've seen. Reliance later informed Yoda that the external threat actors were claiming to have breached data, right? And Yoda couldn't not independently verify the attackers' claims, but provided, its technical findings to Reliance and helped support the investigation. The press agency Reuters, they reviewed the leak material and said it could not independently authenticate every document. The Indian Express also examined the data set, reporting to seeing engineering files, project correspondence, progress reports, site layouts, things like that, right? Project documents. So there's still limitations around exactly what is authentic and what was taken, but Reliance has confirmed this partial breach did occur.
How is that different then from saying the nuclear power plant itself was breached?
Yeah, I suppose we should get specific here, because this is where headlines can get out of control and get irresponsible. The Nuclear Power Corporation of India, or NPCIL, operates the Kudankulam facility. They said that the exposed material related to conventional common service infrastructure known as the balance of plant. The balance of plant includes supporting infrastructure outside of nuclear reactor itself, depending on the facility, and that can include cooling, ventilation, electrical equipment, water systems, buildings, and other services necessary to support operations. They also said that the exposed information did not relate to nuclear safety or nuclear security systems, and that the leaked material also reportedly focused on largely units 3 and 4, which remain under construction, and units 1 and 2 are already operational. So they're saying that there's no evidence the attackers accessed reactor controls, manipulated safety system, or disrupted electricity generation, or created immediate nuclear emergency. The reactor was not hacked. Line should not end the conversation. It establishes the type of incident we're discussing. That it's information exposure involving a contractor, not quite an operational compromise of a nuclear facility, but it does beg the question, does the exposed information, could it still be used as an adversary in something else further, right? And the answer is absolutely could be yes.
Yes, so you beg the question. I will put a bit more flesh on the bones. What could an attacker actually do with the engineering drawings, these meeting notes, or the supply records if they can't control the reactor?
I would say it's the collection. It's the culmination of all this data together. One document might include a building layout, another which contractor installed a ventilation system, or which employee was involved in an inspection, or a photograph of some particular equipment, or a project report that describes a delay or a technical problem or a vulnerability or some issue they ran into, or even just an exact model of a component. Whatever documents, right? Individually, none of those are really that important. But when you bring it all together and you collect it, you can have a detailed picture of the environment, any issues that are arising, or employees that are, like, if you're thinking about conducting an identity attack, or going after some vulnerability or exploit on piece of software, or something like that. All this information is, it could support several types of future activity, right? And that's what's important from all of this, right? They could use a project correspondence to impersonate someone already involved in construction. They could use names, job roles, schedules, I don't know, technical terminology to make phishing or social engineering attempts way more convincing, because they know the type of hardware being used, or the layout, or the vendor and the contractor being done. They could like spoof all of that and some spoofing emails. The engineering drawings and equipment could help the attacker understand which systems are connected, and supporting systems might be important, especially if there's ever a proof of concept on some vulnerability or something like that. I mean, it's really important, right? These stolen documents, they did say, don't contain any passwords or malware to create risk, but the context is valuable, right? The attackers spend considerable amount of time performing reconnaissance. And so, a leak like this may provide essentially years of accumulated project knowledge into sort of one searchable collection. So it may the importance of this may come downstream. Not right now, it might not be obvious, but years down the road, absolutely.
What's the attraction then of attacking the contractor instead of attacking the power plant directly?
Well, honestly, the contractor may hold valuable information without having the same security controls, right? Obviously, they're going to try and have top of the line, top shelf security at the actual nuclear reactor facility, but third party vendors, contractors, engineering firms, construction companies, equipment manufacturers, software providers. I look at big at those ones. All these logistics and data centers and insurers, government agencies, everybody's touched into this. And so each organization may hold a different piece of the project puzzle. And, the operator may carefully isolate its nuclear control systems, but that isolation does not automatically protect copies of engineering drawings stored on a contractor's business server, right? And the contractor needs those documents to perform its work, and it may share them with subcontractors or store them in a project management, database or a platform that maybe isn't secure, and include them with an email, or like, the further you get in disseminating this into further out, like the weaker the controls become, and the easier it becomes, to compromise. And attackers, they know this full well and count on it, to be honest, right? Front door, heavily guarded, right? So they begin looking at a side way in from the sewers or whatever. It's like a video game kind of in that sense, but it doesn't necessarily mean that a contractor has direct access to the reactor. It just means that they may possess information that helps an adversary understand the facility or supporting systems or the people surrounding it, to then provide further follow-up that could be really important, right? The third-party risk cannot be reduced to an annual questionnaire asking whether a vendor uses antivirus or has, multi-factor authentication, right? There's some really important questions there, like, what information does the contractor possess? What does it need with that information? Where is it stored? Who can access it? Are there any subcontractors? Like, how long will it be retained? What can you trust reliably that it's going to be destroyed after the project ends, or they end contract? We get all that stuff. That risk follows that data, and it's tough. It's tough to know even when the data leaves the owner's network, where is it going, right?
Let's play the blame game then. Reliance said that the data was on a server hosted by Yota. Does that make the data center provider responsible for the breach?
I don't know, not based on the information currently available. Um, that's where the phrase hosted by a third party a lot of times creates confusion or the blame game, like you said. A hosting provider can secure the physical data center and the underlying infrastructure while the customer remains responsible for the actual server or operating system or accounts, configurations, and the data itself. I mean, we don't really know which layer, which section failed. Yada said it detected the terminated suspicious activity and prevented the suspected ransomware execution. But, we don't really have full details there either. But it does suggest that they had some visibility and took some action. But we don't know whether the attackers had already, exfiltrated information and accessed the server. Who is responsible for the compromised control? It definitely illustrates sort of a shared responsibility here. And moving a server to third-party data center does not transfer every aspect of cybersecurity to the provider. And the customer still needs to understand which controls the provider manages and which controls are your responsibility, remain your responsibility. And so this applies a lot to cloud services. And a lot of organizations sometimes say, like, the data is in the cloud, as if it's like location answers the security question when it clearly does not, right? Who manages identity, who configures the access, who monitors the activity, who applies the patches? That's a big one right there. Who controls the encryption keys, who retains the log. I mean, these are all responsibilities that must be explicit before an incident and, not debated or blame game afterward.
Now, Yoda said it prevented the suspected ransomware execution. If that is accurate, how did this still become a major incident?
Yeah, I don't know. I agree. That leaves room for speculation on how accurate it is. But, because ransomware execution may be the final visible step of a much longer intrusion and reconnaissance that they may have done. And so attackers spend time collecting credentials, identifying valuable systems. They move laterally, data exfiltrate. They looking at documents trying to find out who they hit. Were they trying to hit you to begin with? Did they discover, oh my God, this is a nuclear reactor facility. This is really cool. This could be worth way more. Like, let's look at some financial documents. How much money do they have in the bank? And do all this exfiltrating and casing of the joint, if you will, before they attempt to actually encrypt anything. So if defenders block the encryption payload, okay, but the attacker still already stole like hundreds of thousands of files, and the organization, they prevented part of the attack, but not the entire attack, right? That data that they got is still valuable and is still an attack, right? Still very valuable defensive success. But the attackers retain extortion leverage through that stolen information. And so, yeah, we don't even know fully what's been confirmed, or when and well or how the files were taken or the reported timeline or any of that stuff to really pass any sort of reliable judgment here. So just saying ransomware blocked does not mean the investigation should stop there, right? There are a lot of other questions I would want to ask, like, how did the malicious activity begin? What was your first indicator of compromise or attack vector? What credentials were used? Which employee? What happened before the ransomware attempt? Was there, how much did you see any anomalies in, like, network activity and the data exfiltration from what servers or what? A lot of stuff you gotta ask. And yeah, did they access backups or administrator tools? Right? There's a lot of, like, blocking the payload that they mentioned they did. It's good, right? But determining what preceded it is absolutely essential.
This is apparently not the first time that this particular nuclear reactor has been connected to a cybersecurity incident, isn't it?
Yes, you are correct there, and that is interesting. In 2019, there was a piece of malware called D-Track was discovered on a computer connected to Kudon Kulam's administrative network. And they linked that specifically to North Korean activity, and that makes sense. Nation state sponsored attackers love to go after critical infrastructure, and, like, let's be real here, nuclear power plants are the gold mine of critical infrastructure. And so, that case and this latest incident, I don't think they're really connected. We don't know for sure, but I mean, the actors affected organizations and the circumstances essentially are different. But comparing them does reveal, two different ways information can be exposed around critical infrastructure. So then 2019, that malware reportedly reached an administrative network within the plant. And in that incident, files reportedly came from a contractor working on a non-nuclear infrastructure for units under construction. That's what happened in this incident, right? And so neither incident is evidence that reactor was compromised, obviously. Both demonstrate that protecting the reactor controls is only one part of the larger ecosystem, and critical infrastructure produces enormous amounts of sensitive administrative, engineering, and operational information. And that information and securities, they exist way beyond the control room.
Okay, then, starting to tie things up now, let's move on to the learnings section of this episode. What should operators and organizations with sensitive contractors be drawing from this?
Yeah, it's tough. I mean, nuclear power plant's one of the top out there, but I'm sure there are some listeners out there that maybe work with organizations or defense contractors, things like that. You definitely want to classify project information based on how it could be, used in combination, not simply how sensitive each individual document appears, right? The combination together. The vendor list may not be secret. The building a diagram may not be secret. A project schedule may not be secret, but you complete the collection and you provide way more intelligence than any individual file. So you want to make sure you minimize contractor access and retention. Onboard them like employees if you can. They should receive the information required for their specific function, not an unrestricted archive of an entire project. And the access should absolutely expire when the work ends, and unnecessary copies removed and their permissions removed, things like that. Include data handling and third-party, security requirements. Right? The contracts specifically, they should specify where sensitive files can be stored and viewed, right? Whether subcontractors can access them, what logging must be retained, right? How incidents are reported and when data must be deleted. And obviously monitor for anomalies, for unusual collection and data exfiltration and, network throughput. If an account suddenly accesses hundreds of thousands of project files, it creates large archives and transfers an unusually large volume of information, that activity should generate an alert or at least attention if no malware has been detected, right? And so also lastly, I guess, plan for disclosure involving partners, right? So the operator, contractor, host provider, the government potentially, they're probably each going to possess, part of the picture, and they need to be predefined of communication investigation procedures to avoid delays and conflicting public statements. I guess the end of this, assume that exposed information will be retained indefinitely, right? Passwords can be changed, systems can be rebuilt, but a building layout or an engineering drawing, you can't make that obsolete. You can't just patch that or change that, right? Once sensitive design is public information, the organization may need to reassess like physical security, vendor relationships, social engineering exposure. All that stuff comes downstream from that, right? It's really important.
Finally then, Tyler, what is the main takeaway, do you think, from this incident?
So I'd say the most protected system does not exist in isolation. There is no evidence that world leaks compromised the reactor or nuclear safety systems, or even the nuclear security systems, but attackers reportedly obtained thousands of files from a contractor involved in surrounding infrastructure, right? And the information that identified facilities, equipment, suppliers, employees, project dependencies, by itself really are fairly benign, but together as a big, larger picture, they help an adversary plan a more informed cyber attack, whether it's a social engineering campaign, supply chain intrusion, or some intelligent operation later, right? And so organizations, therefore, need to protect more than the crown jewels themselves. They must understand who holds the copy of all these blueprints and where they're stored and how many other companies can access them. Because attackers may not need to breach the vault if everyone involved, in the building is carrying pieces of the map.
Tyler, fantastic, fascinating stuff as always. Thanks so much.
Hey, thanks for having me on, Ben. I appreciate it.
Reimagining Cyber will, of course, be back next Wednesday. In the meantime, please do remember to rate, review, and share the show. Goodbye.